Hello Seekers, welcome to my channel Science Seekers. Today we are discussing another interesting topic, that is electrostatics. Electrostatic is the study of electric charge at rest. The electrostatics means the study of electric charge which is at rest position. So what do you mean by electric charge? Electric charge is an intrinsic property of the elementary particles like electron, photon, neutron, etc., which gives rise the electric force between the various objects. Which gives rise the electric force between the various objects. And electric charge is a scalar quantity, and its unit is coulomb and stat coulomb. And the charge of proton is positive always, and that is 1.6 into 10 to the power minus 19 coulomb. The charge of electron is negative, that is minus 1.6 into 10 to the power minus 19 coulomb. Laws of electrostatics. There are only two kinds of electrostatic charge that exist, that is positive or negative, which the like charges always repel each other and unlike charges attract each other. To discuss about the properties of electric charge. What are the properties? First property is the adductivity, and next is conservation, and third is quantization. What do you mean by adductivity? Adductivity is the total charge of the system in an algebraic sum. Total charge of the system in an algebraic sum of the individual charges located at the different point of the system. It means let some charges are q1, q2, q3 dot 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 n number of charges there are in the system. So in the property of additivity, the net charge q is the sum of individual charges. That means the sum of q1 plus q2 plus q3 dot 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 so on and dot, that is the n number of charges, that is qn. The next property is the conservation of charge. What do you mean by conservation of charge? Conservation of charge means the total charge of the system remains constant. Total charge of the system remains constant. That is the conservation of charge. The electric charge can neither be created nor be destroyed. They only transfer from one body to another body. It means the electric charge होता है वो created नहीं होता है और destroy भी नहीं हो सकता है. वो create भी नहीं हो सकता है और destroy भी नहीं हो सकता है, लेकिन जो charge है वो one body to another body transfer हो सकता है. Next, the quantization of charge. Quantization of charge. A charge small q of a body is always an integral multiple of the basic quantum of charge E. Mathematically, the charge q here, that is n into E. The charge is small q and the basic quantum of charge is denoted as small e. So q equal to n e, where n is an integer, that is 0 plus or minus 1 plus or minus 2 so on. To discuss about Coulomb's law. Coulomb's law states that the magnitude of the electrostatic force between the 2 point charges is directly proportional to the product of the magnitudes of the charge and inversely proportional to the square of the distance between them. The magnitude of electrostatic force between the 2 point charges. 2 point charges, let a point charge is q1 and q2. It directly proportional to the product of magnitude of the charges. Means electrostatic force F is directly proportional to 2 point charges, let q1 and q2. F is proportional to q1 and q2 and inversely proportional to distance between them. Hence there are 2 point charges q1 and q2 and the distance between q and q2 is r. So F is proportional to q1 and q2 and F is inversely proportional to 1 by r square. So F is proportional to q1 q2 by r square. In the next step, we remove the proportionality sign. So F is equal to k into q1 q2 by r square. That is the equation number 1, where k is the proportionality constant or electrostatic force constant. So the value k is depends upon the medium the charges are kept. It means the charges are in the system, where k is equal to 1 by 4 pi epsilon naught. Epsilon is the permittivity of the medium. So the above equation 1 will be written as F equal to 1 by 4 pi epsilon into q1 q2 by r square. So F equal to 1 by 4 pi epsilon naught epsilon r into q1 q2 by r square, where epsilon r equal to epsilon by epsilon naught and epsilon equal to epsilon naught into epsilon r, where epsilon r is the relative permittivity and epsilon naught is the electric permittivity or the permittivity in free space. Permittivity in free space. For air medium, epsilon r equal to 1. So the equation will be reduced to f equal to 1 by 4 pi epsilon naught q1 q2 by r square, where 1 by 4 pi epsilon naught value is equal to 1 by 4 into pi का value 3.14 into epsilon naught का value 8.85 into 10 to the minus 12. So that is 9 into 10 to the power 9 Newton meter square per Coulomb square. That is the constant epsilon naught is called the permittivity of the free space, and its value is 9 into 10 to the 9 Newton meter square per Coulomb square. So the vector form of Coulomb's law, let's consider 2 point charges q1 and q2 placed r distance apart. Then there will be two charges q1 and q2. The force q2 due to q1, that is f21, and the force q1 due to q2 is f12. There are 2 point charges, that is q1 and q2. From q1 to q2 the distance is r12, and from q2 to q1 the distance is r21. Using Coulomb's law, the force on the charge q2 due to q1, that is f21 equal to 1 by 4 pi epsilon naught q1 q2 by r square into r12 cap, that is r12 cap equal to r12 vector divided by r12 vector ki mod. R12 cap equal to r12 vector divided by r. The force of charge q1 due to q2 equal to f12 equal to 1 by 4 pi epsilon naught q1 q2 by r square into r21 cap, that is r21 cap equal to r21 vector divided by r21 vector ki mod. So r21 cap equal to r21 vector divided by r. R21 cap is equal to negative of r12 cap. The distance of r21 is equal to the negative sign of distance of r12. So the force equal to f21 equal to negative of f12. So the mod of force f21 is similar to the mod of force f12. Here, as a result of Coulomb's law of force is in the according with the Newton's third law of motion. So the unit of charge is, the SI unit of charge is Coulomb, that is 1 Coulomb equal to 3 into 10 to the 9 start Coulomb, or 3 into 10 to the 9 ESU of charge or electrostatic unit of charge. Force between two similar charges q1 is equal to q2 is 9 into 10 to the 9 Newton. Then the free space or vacuum, then the charge is said to be 1 Coulomb, and one ESU or one electrostatic unit is the two similar charges q1 equal to q2 at 1 centimeter distance, which repels each other in a vacuum by a force of 1 dyne. Then the charge is said to be 1 ESU or 1 electrostatic unit of charge. So that is today's course. In further classes we will discuss about another interesting topic. So I hope you all understand the class. For any queries, do comment. If you guys like the video, just like, share and subscribe for more interesting topics in future. See you all in the next class. Thank you guys.